Hi kids, meet Gia, your instructor for today's video. Have you wondered how atoms position themselves when bonded with other atoms? Since atoms are surrounded with negatively charged electrons, positioning them with another atom, forming a molecule, will cause a repulsion. So how does an atom position themselves such that they can minimize repulsion? We can answer this question through the VSEPR theory. Valence shell electron pair repulsion theory tells that in order for atoms to minimize repulsion, they should form a geometry that separates them as far as possible from each other. Let us see beryllium fluoride. The VSEPR theory tells us that bond pairs will take the spot that is as far away from each other as possible. In this example, since we have two bond pairs, one Fe atom will be on this side and the other will be on the opposite side. Notice that they are forming a 180-degree angle. The electron pair geometry of this molecule is identified to be linear. What if there are more than two bonding pairs? Let us take a look at beryllium trifluoride. The VSEPR theory says that all electron pairs assume positions of least repulsion, so iron atoms will be positioned towards the corner of an equilateral triangle. If we measure the bond angle, we will know that the FBEF bond will be at 120 degrees. This now forms the trigonal planar geometry of the molecule. The two previous examples only discuss the geometry of molecules that only have bonding pairs. What if we introduce the concept of non-bonding pair or the lone pair atom in the equation? What will the molecule look like? Let's consider ammonia. Nitrogen has 5 outer electrons and only forms 3 bonds with hydrogen atoms. Then, one of the pairs must be a lone pair. Following the VSEPR theory, hydrogen atoms will arrange themselves in a tetrahedral manner. The repulsion involving a lone pair is greater than the repulsion involving a bond pair. This will result in a decrease of bond angles between atoms. The presence of lone pairs makes the molecular geometry of ammonia to be trigonal pyramidal, and slightly reduces the bond angle from 109.5 degrees to 107 degrees. In summary, we have learned that atoms will arrange themselves as far away from each other as possible to minimize repulsion. Additionally, molecular shape can be determined by the number of bond pairs and lone pairs. Lone pairs in a molecule will have higher repulsion than bonded pairs. With these concepts, you are now ready to face molecules with multiple bonds and lone pairs of more than one and determine their molecular shape using VSEPR theory.
Created using Powtoon.